Right. We're going to approach the same way, and at the end we end up at a slightly different situation, so I'm suggesting one more step, and that's going to be the same for the next problem as well. So what was the method we've been doing so far? Left hand side and simplify, right hand side simplify, and hope they're equal to each other, right? That's what we've been doing. So we're going to do that together. That's your exercise first. Exercise, let me first write down and the left hand side part because I have some thought about left hand side. Left hand side is equal to cosine u divided by 1 minus sine u. I just copied it down, and you can't quite simplify 1 minus sine u in the denominator any further. Right? If it is a numerator, you think about splitting it, but if it's in the denominator, you can't. It's already in the sine cosine, and that's good enough. So it seems like that's simple as it gets to me. And Pythagorean identity that is required for the test is this one, sine squared plus cosine squared theta equals 1, right? So that's why we write everything in terms of sine and cosine. And for the homework, there are more identities out there. I listed some of them that is very useful to do the homework problem in the discussion area. But for the test, and this is the only thing we're going to use. All right, so that's left-hand side. Right-hand side is your exercise. Exercise. Here's your right-hand side. And I want you to think about what to do with the right-hand side. Not too bad, so I'm going to leave it as an exercise. So I hope you got down to this much. Okay? The problem is that this seems like simple enough. Everything is sine and cosine. We haven't used Pythagorean identity, and they don't look equal to each other, right? So here's a third thing that we're trying. We separated left-hand side, right-hand side, simplified, wasn't equal to each other. So here's an idea. We're going to put them together like this: left-hand side minus right-hand side. If they're actually equal to each other, and if you're putting these two things and try to simplify it all together, what's going to happen at the end if they're equal to each other? It's supposed to be 0, right? Okay. So once you write it like this, we practiced on how to combine these things and simplify. So I will leave that as an exercise. First, I'm going to copy it. Left-hand side is cosine u divided by 1 minus sine u minus right-hand side has a new version right here. So that goes in here. 1 plus sine u divided by cosine u. All right, that's what it is. And see if you can simplify this one. So what do we do? Common denominator, right? So that's your exercise. So here's a simplify this one that we just wrote down. Alright, let me talk about this common denominator part. So I had to multiply cosine u and 1 minus sine u for the both term like this to have a common denominator, right? Is that okay? Right. So I wrote down this thing, a plus b times a minus b. Do you know why I wrote this one down? Do you see that form that is appearing somewhere here? There's a plus b, a minus b there, right? You can multiply it out, but it's something that shows up a lot in Pythagorean identity. It's useful formulas. You know what happened if you multiply these two, a plus b, a minus b? Yeah, cancel out, and what is left? A squared minus b squared. That's what is left. Okay. If you see a plus b, a minus b, that's a squared minus b squared. A very useful thing appeared a lot in quadratic algebra. So let's write this one down all together. The denominator is going to be 1 minus sine u cosine u. That's common denominator. First term is now cosine squared u, right? Minus this thing, a plus b, a minus b is a squared minus b squared. So it's 1 minus sine squared u. Is that right? I didn't use Pythagorean identity. This is just an algebra, right? A plus b, a minus b. All right. Now in the numerator, we have sine squared and cosine squared. If we can think about It is time to use what? Pythagorean identity, right? So let's write that down. Sine squared u plus cosine squared u equals 1. That's Pythagorean identity. So what do you do? Which one do you want to substitute? You see that you can rewrite this one or that one, right? Whatever is your choice. So let's do cosine squared. So if I isolate cosine squared u here, that's 1 minus sine squared u, right? But you see that even that 1 minus sine squared u now appears to be just cosine squared u. It seems like whatever way you substitute, you will get what you want. So I decided this looks easier to me, although that wasn't our plan. 1 minus sine squared u is now cosine squared u, and whatever is in the denominator. Copied it here. Right? Then what do you see? Cosine squared u minus cosine squared u? 0. Whatever is in the denominator, numerator 0 is 0. As long as the denominator is not 0. So what happened? Yeah, left-hand side minus right-hand side. And we worked it out. It was identically 0. That implies that left-hand side is actually equal to the right-hand side, which wasn't immediate just looking at left-hand side or right-hand side. Okay? And especially when you simplify left-hand side and right-hand side, we didn't use Pythagorean theory, Pythagorean identity, right? And it kicks in a later stage. So this is the third. One more thing I asked you to. Whenever you simplify left-hand side or right-hand side, they're not equal to each other. This is usually the things to do. Left-hand side minus right-hand side. All right? So we're going to apply that same strategy to the next example if there's any other question. Is there any question about you didn't hear? It's something you have to practice a lot so that it comes out fluently. Here's the second and last problem of the identity part. This is one problem. Some people like to factor and manipulate. And the method I'm going through in here is just I'm trying to be consistent so that you understand this method better. But there are people who like to manipulate things on their own way. And sometimes it's better. Okay? So I think we will have time to discuss the shortcut of this one. But I think it's still worth to, put forth our consistent method and see where we go with this one. So that's first. That's a bit lengthy, and we're going to come back and think about a different method. All right. What do you see about left-hand side? Yeah. What did you say? Right, it's already sine and cosine, so it seems simple enough, and I'm not going to touch it. Right-hand side, there's tangents and secant, right? Right. Do you know there is some nice Pythagorean identity? It's not required for the test, but there is something about tangent and secant. Remember that? Yeah. If you use that, the answer will be shorter. And if you remember those, you can use it. But I'm just going to pretend here I don't see that. I'm just going to go to sine, cosine, and figure out from there. So right-hand side, there's a little help there. So I'm going to do this part together. All right. So what are you going to do about that tangent guy? Right. It's a sine theta divided by cosine theta, right? Whole thing is squared. Denominator? 1 over cosine theta minus 1. So it's a fractions over fractions. And if you can simplify nicely, it would have been better. And that's the part that I wanted to do with you guys. So I want you to think about it like this. I have, let's say, compared to that one, 7 divided by 5. Let me go further. What can I do with the square? Can I distribute it there? Right. So it's a sine square theta, cosine square theta, and there's just cosine theta minus 1. There are multiple different ways to rewrite this one as a simpler. The one that I explained, I think has some advantage. I hope you agree. All right, here's the thing. If you see 7 over 5, that's like this. but it's squared. And I wanted to multiply the numerator and denominator the same thing so that it's the same as before. By doing that, I wanted to take care of these denominators. This is there. I want to take care of it. So what should I multiply here to get rid of this 5 squared? 5 squared, right? Is that okay? If we multiply that, these cancel and get rid of the denominator. So what do you want to multiply here to get rid of that cosine squared? Cosine squared. So just multiply there, and as you multiply to the numerator, that's going to knock that out and make the denominator simple. How about the denominator here? What do you want to multiply? Just the cosine, but you can't do that. Just multiplying the numerator something and denominator something else. You can't do that. So you have to put this cosine squared theta there and see what happened. It's kind of overdoing the denominator, but it's still doing it, right? Still takes care of the denominator. But all you need is just one copy of a cosine, correct? So if you do that, your denominator is in a factored form. Whenever you have to combine the new common denominator, factored forms are better. All right? So let's do that. I'm going to multiply to the numerator. How many terms do you see in the numerator? There's only one term. These are two factors. How about in the denominator? How many terms do you see? There are two terms. When you multiply, you got to multiply everything to each term. But if there's only one term, you multiply only one time to that, not numerator and denominator both. Right. So what happened if you multiply 7 squared, 5 squared by 5 squared? They cancel, just leaving that numerator here. So what survives in the numerator? Sine squared theta. Now denominator, we're going to only use one copy. So let me do it this way. Cosine theta minus 1. Cosine theta go in there. And leave one copy out there. Leave the... this decision is based on the experience, knowing just the answer. You don't go this smoothly in the actual answer, right? But you will discover factoring is a good idea. So we're going to multiply cosine in there. What happened to the first term? Cancel. It becomes what? 1. And then minus cosine theta and cosine theta out there, extra cosine theta out there. If you'd have just multiplied cosine squared all over, then you're going to have cosine minus cosine squared. And then you have to be able to recognize there's a common factor, cosine, so factor it out. Again, keeping the denominator in this form, factored form, is better when you enter this stage and try to combine the common denominator. So that seems like as simple as it gets. Cosine. Is that okay? Now, left-hand side and right-hand side, they don't look like each other. So what do? Subtract them. Here's a stage. Some people have a different idea. If you see sine squared, what comes to your mind? Something comes to your mind? 1 minus cosine squared, right? 1 minus cosine squared looks a lot like 1 minus cosine. Do you know how they're related? Here's the answer. If you see 1 minus cosine squared, but how is it related? 1 minus cosine times 1 plus cosine. Right? So if you see that kind of thing from here, answer will be a little bit quicker than what we do. Factoring method. So you observe, hey, that's a sine squared. I'm going to change that to 1 minus cosine squared and then factor to 1 minus sine, 1 minus cosine times 1 plus cosine. Hey, that 1 minus cosine cancel, and so on. Some people like those and some people don't. All right. So this is the version that those people don't see that. Left-hand side minus right-hand side. So left-hand side is what? 1 plus cosine theta cosine theta. Minus right-hand side sine squared theta 1 minus cosine theta times cosine theta. So from here is your exercise. But I want you to note that these two denominators has some common parts already, right? There are some common parts, so use that. Don't just automatically multiply those two things. They already have common factors. If you use that, your calculation will be better, actually. Was that okay? This expanding 1 plus cosine times 1 minus cosine, that will be the thing to remember again to do this quickly. So a plus ba minus ba squared minus b squared, so it's 1 minus cosine squared. Now you have cosine squared and sine squared. Use Pythagorean identity to make it equal to 0 again. So, any question about this one? Is that right? Then I'm going to go back to the problem, and this was the length of the solution right here. Okay. And who remembers anything about tangent and secant? Anybody remember the what is it? Identity that involves tangent and secant? That was shown right next to sine squared plus cosine squared. It looks like this. Tangent squared, right? Theta plus 1 equals secant squared, then, right? So some people look at it, hey, there's a tangent squared. I'm just going to replace it with secant squared minus 1, right? So the right-hand side is simply secant squared minus 1 divided by secant minus 1. Is that right? That's how it's rearranged. Now you're looking at a squared minus b squared divided by a minus b, right? Does that look like it? Can you factor this one? Secant theta plus 1 secant theta minus 1 divided by secant theta minus 1, right? Then the secant theta minus 1 cancels. So it becomes secant theta plus 1. And now you compare, it's a lot simpler, compare with the left-hand side. I'll show how they compare. So I decided to change, well, left-hand side is a cosine, so why don't we change the cosine like that. And then if you put a common denominator, it becomes like that. So that there's a proof. If you like to, memorize a few more identities, and it speeds up the proof a little bit. But if you stick to the sine and cosine, it goes like this. All right. That's but at least it's consistent in the method. Is that okay? Any question? So that is the one thing that we need, this fundamental Pythagorean identity, to re-express these terms so that we recognize something is look different, but they're actually equal, things like that, right? There are more identities. The next identity we're going to go through is very, very important.